This video is going to discuss graphing absolute value inequalities, and this is really similar to our last lesson, which was graphing absolute value functions. We're going to see that it's really just one more step. So our instructions are here. It says create a table of values, making the vertex the middle row. That's all the same as last time. But when we draw our line after we plot all our points, we're going to use a dashed line if we have less than or greater than. And we're going to use a solid line if we have less than or equal to and greater than or equal to. Okay, so we're going to have to choose between a solid line or a dashed line in these graphs. Then, if the symbol is greater than or equal to, then we have to shade above the line, and if it's less than or equal to, we'll shade below the line. That'll make a lot more sense as we apply it. So let's go ahead and dive right into an example. Remember, number one is to create a table of values. In order to find the vertex, we take this value that's inside the absolute value bars and set it equal to 0 and solve. So we're going to get x equals -1. And so we'll put that -1 right here. Now we want to see when we plug -1 into our function, what do we get? So if we put -1 in here, we're going to get -1 plus 1. And -1 plus 1 is 0. So the absolute value of 0 is just 0. That's what's going to go here. All right, now we need to fill in the rest of our table. So we'll go back 3 units and forward 3 units. And then we will plug each one in. And we're treating this like an equation right now. And then we'll talk about what the inequality symbol tells us in a minute. So for the sake of filling in our table, we're pretending that this says y equals the absolute value of x plus 1. So when we put our -2 in for x, we have the absolute value of -2 plus 1, which is the absolute value of -1, which is just 1. When we plug in -3, we're going to get -3 plus 1 inside, which is -2, and the absolute value of -2 is +2. Okay, then when we plug in -4, we're going to get absolute value of -4 plus 1, which is -3. And then the absolute value of -3 is 3. And if you remember, as long as these are spread evenly, and they are all 1 unit apart, then we can reflect these answers across the vertex. So it's going to be 1, 2, and 3. Remember, these match each other. All right, so we've completed step 1. We created our table of values. Now it wants us to graph. So we are going to plot the points like we normally do, but before we do a line, we're going to talk about the difference in a dashed line and a solid line. So let's get the points on our graph first. So we go left 4 and up 3, left 3 up 2, left 2 up 1, left 1 up 0, over 0 up 1, right 1 up 2, and right 2 up 3. Okay, but now whenever we look here, we have a less than symbol, not equal to and not greater than. So our less than symbol is found right here and right here. So that's going to tell us how to continue drawing our graph. So it says to use a dashed line for less than. Okay, so what the dashed line tells us is that it cannot equal the graph, but it's going to get real close to it. So we're going to draw a dashed line with an arrow at the end, both ways. Oops, got a little crooked there. All right, so this is what our graph looks like so far. We've graphed it and we used our dashed line, but then we need to shade above or below the line to show what values work for this. So the less than symbol says we should shade below the line. So we are going to use we are just going to shade all of this in. I know I'm doing a beautiful job. Thank you. All right. And so what this is telling us, if we were just to see the graph, that would mean this tells us that for whatever this relationship is, whatever the function is talking about, we don't really know what the x and the y mean or what scenario in real life this could be. But it tells us that for, like, let's say this x value. So if x was equal to 6, that's where that's at. That means that any y value less than this point will work for that value of x. So, like, let's test a point. If we put x equals 6 in, if we have 6 here, we're going to have absolute value of 6 plus 1, and then absolute value of 7 and 7. And this is an inequality. So y has to be less than 7 to work for x equals 6. Well, if you look, when y equals 7, that's where our line is, and that's where it stops working. But all the numbers under there work for x equals 6. All right, I hope that made some sense. If you get too lost in the how and why, just pay attention to your instructions here. They're pretty clear and easy to follow as long as you can remember what they are. So let's do one more example, because these are exactly like the problems you were doing yesterday. You just have to question, is it a solid line or a dashed line? And do I color in above the line or below the line? And the instructions tell you what to do depending on the symbol that you use. So these are the same things that we were doing in the last lesson with just a couple extra steps. So the first thing to do is to find the vertex so we can make our table. And remember, the vertex, we take only what's inside the absolute value bars and set it equal to 0. And so we're going to get x equals 5 for our vertex, our x value of our vertex. And then we're going to plug 5 in for x to see what the y will be. And remember that when we are substituting values in, we are pretending that this is an equation and not an inequality for a minute. So if we plugged in 5 for x to see what the y value of our vertex is, we are going to get the absolute value of 0 minus 2. And the absolute value of 0 is just 0. Minus 2 is negative 2. So that's what's going to go here. Now let's go down from 5 and up from 5. And then we're going to plug each of these values in. So I'm going to just think through this instead of going through it. We're going to talk instead of write. But if we plug 2 in for x, the first thing we do is 2 minus 5. 2 minus 5 is negative 3. The absolute value of negative 3 is positive 3. Positive 3 minus 2 is positive 1. Okay? I'm going to talk through that again. Only because I want you guys to have some experience with thinking through mental math. And I know that sometimes it's hard to teach mental math, so I'm going to try to talk you through my process. The next value we're going to plug in is 3. So 3 minus 5 is negative 2. The absolute value of negative 2 is positive 2. Positive 2 minus 2 is 0. All right, 4. 4 minus 5 is negative 1. The absolute value of negative 1 is positive 1. Positive 1 minus 2 is negative 1. All right, and we've talked about how our points should mirror each other around the vertex. So we can just fill these in from knowing the first 3. And then we're going to put those on a graph. So 2, 1, 3, 0, 4, negative 1, 5, negative 2, 6, negative 1, 7, 0, and 8, 1. And then we have to see what kind of line we're supposed to use. So this is a greater than or equal to symbol. So that is this guy and that is this guy. So this says we're going to use a solid line. So solid line. All right, and then we need to know, do we shade above or below? And this says to shade above the line for greater than or equal to symbols. So we are going to shade above the line. All right, and that is all for number 2. So I want you to go ahead and finish the rest of the worksheet. The vertexes are listed on the answers in your binder. And yeah, let me know if you have any questions. Shoot me an email. Hope you guys have a great day.